All right, welcome back for week 2. This time we're really just gonna jump straight into the programming part, and I'm gonna try to record it straight to the cloud so that you'll have easier access, and also so that I don't have to upload a file that's like 8 gigabytes to YouTube. So let's see how that goes. I probably will do it in 2 parts. So this first part is going to be the lecture where we're going to talk about a lot of different programming constructs. And then the second part will be the lab where we'll go over those same constructs, but actually hands-on, and you'll follow along using Jupyter Notebook. Okay, so let me just share my screen and start the PowerPoint. All right, so this week we're really going to go into like a lot more about programming. Just to recap from last week, hopefully last week you're on the same page and we reviewed the course outline and objectives. We also installed Anaconda and learned about Jupyter Notebook. We also wrote our very first Python commands. Hopefully you had some fun playing around with those and like manipulating different variables and just kind of trying to see what comes out if you change what your command is. A lot of the commands that we wrote were simple single line commands, which printed straight to your screen. And you could also perform some basic like math operations and things like that. And then we also briefly reviewed one Python IDE called Spider, which is basically just another way to write code in Python or another environment that you can use. This week, we are going to do a whole lot more. So we're going to talk a little bit about command line prompts just so that you have a little more idea of what they are. We also are going to cover basic data types, variables, conditionals, syntax, conditional statements, basic functions and libraries, and then reading and writing files. So really going to get into it. Hopefully by the end of this session, you will know what each of these words I just said is. All right, so in terms of command line, in the last lecture, I talked a little bit briefly about graphical user interfaces or GUIs, GUI, versus command line interfaces or CLI. Most programmers, I think, generally use some sort of command line interface because it's a lot more flexible. And when you're writing thousands of lines of code, you really just want something where you can write a lot of lines of code at once. Or they'll use an IDE, which is an interactive development environment, which we also talked about, which is like what Spider is. However, I did want to just show you the command line so that you get a little idea of what it looks like. And so one of the easiest things that we can do right now is to open Jupyter Notebook. We have a few different ways to do it. The way we did it last week and the way that you could continue to do it is you can open Anaconda Navigator on your computer, which is a GUI-based software program. And then from there, you find the Jupyter Notebook and you click open, right? So that's pretty straightforward, and that would be the GUI-based way of doing it. However, you can also type a line of code that will open Jupyter Notebook from a command line. So let me just tell you a little bit more about command line prompts. So we don't use them, we will not use them a lot in this class, only because they really differ based on your operating system. So your operating system would be like whether you're on a Mac or a Windows or a Linux computer. Like I said before, if you're on a Linux computer, you probably don't need this class because you probably know quite a bit about computers at that stage, because Linux has a lot more of the command line interface and a lot less GUI, and it's a little bit more challenging to use, some might think. So most of you are probably going to be either on a Mac or on a Windows computer. And I will show you this when we get to the lab part. But basically on a Mac, you're going to use the search icon at the top right corner of your computer. You'll type the word terminal, and it'll give you an application called Terminal. And the terminal is how we communicate directly with the computer on a Mac system. So then you'll just type in Jupyter Notebook in all lowercase at the prompt, and it will open Jupyter Notebook the exact same way it would if you clicked Jupyter Notebook in Anaconda Navigator. Like I said, I'll show you this because I think it may not make as much sense just talking about it. But I did want to go through all the lecture and give you everything that we're going to do, and then we'll do it all together. So this is actually what the terminal looks like. In here, you have what's called the command line prompt. So this is this information is just like, this is what time that you last logged in and what type of shell you're using. These are all things that are probably a little more complex than what you need to know, but they'll pop up every time you open a terminal, and yours, this information up here might look different for you actually. But what you should have is something where it says, whatever the name of your computer is, whatever the name of your username or user account is, and then this $sign, which is a command prompt. And maybe that looks different on different computers. Sometimes it's like a hash or a colon or %, etc. But it will be something like this. And then if you click in this area, it will give you the chance to start typing text. And that's where you would just type Jupyter Notebook. Jupyter Notebook in this case is your command. So this is the command line prompt. This is a command. And this whole thing together that in the terminal is the command line interface on a Mac system. On a Windows computer, it's going to look slightly different. So you should be able to go to the bottom left of your screen, and you have that search or start button that has like the little window icon. Or to the right of that, it usually has a little window that says type here to search. So in either of those, you can type in the word Anaconda prompt, because this is what the application is called on a Windows computer. You will open the Anaconda prompt application, and it will look a lot like the terminal window I just showed you, except it's for Windows. And then you will again type Jupyter Notebook, all lowercase, and it will open a Jupyter Notebook in your Chrome browser. On Linux, like I said, I don't think anyone has a Linux system, but just in case, Linux has like what's called a native terminal interface. So you just open the terminal from Linux and type Jupyter Notebook. In either case, in each of these three cases, there are just all three different ways that you can get to the terminal and type a command prompt. So there's a few differences in terms of your operating system and command line prompts. And so that's why we're not going to go too far into it, because otherwise we'll have to talk about everything one way on Windows and then another way on Mac. But basically, Macs have what's called a native Linux-like system. So it's a native terminal as well. So we can do a little bit more from the command line using a Mac. Windows doesn't really have native terminal access. It has something else called command prompt, or you can type from the start button CMD, and it will open up like command prompt window, but it doesn't accept the same commands that a native terminal does. So it's a little bit different. And then there's another difference, which is like file pathways. The way that you type a file path across directories is different. So it's a / on Mac and a / on Windows. So these are just some things that make it incompatible to do exactly the same thing together, which is why we've chosen to use things like Jupyter Notebook, Spider. For Unity, we'll use a game development game engine that works on Mac or Windows. So this way we won't have to do everything twice. But I think it's just a little bit important to understand that when you really get into the nuts and bolts of programming, or if you decide you really want to be like a Python person in the future, there are some things you have to consider in terms of which operating system you're using. Okay, so the rest of this should apply no matter what operating system you're on. But the first thing I wanted to cover today is basic data types. So in addition to the binary code that we talked about last time, your computer also needs to know what data type is being provided to it, because each data type has different properties, rules, and operations. At this point, I think I'd like you to pause and watch this short YouTube video. So the link is here, and I will also include it in the lecture and the announcements so that you'll have the link straight there. It's only about 3.5 minutes, but it will tell you about what data types are and why they're important. Okay, so I'm going to assume that you watched that video, but in a nutshell, different data types have different properties and are allowed for different operations. So like you saw in the video, numbers like integers and floats can be used with math operations, but strings can't be used with most math operations because it wouldn't make sense. So for instance, you can do 5 divided by 5, and a computer knows that if they're numbers, you can divide 5 by 5 and the answer should be 1. But if you were to say divide hello by goodbye, you would definitely get an error because the computer has no logical rule for that. And neither do we. It's just not something that exists, right? There was a typo in the video though, and the one math operation that can be used with strings is plus. So what you can do is add 2 strings together and it really just joins them. So in this case, if you have in quotes, and note that the quotes denotes that it's a string, even though it is a number inside the quotes, the quotes tell the computer that the data type is string. So if you did in quotes 11 plus 1, you would actually get 111 because it's just concatenating or merging those two things together. If that's not clear to you or you're a little bit confused still, when we get to the lab, it's a great place for you to replace different letters and numbers and strings and try to test out different scenarios so that you can understand it a little better. And again, just so you can understand, if something is in quotes, it's a string, even if in the quotes, it's a number. Whereas outside of quotes, the computer will automatically read that as a number. All right, so this can also be a mixed bag that we can go down, but the important thing is to understand different data types have different properties, because this is also a common place where we'll get a lot of errors. So like in the video, there's a lot of different data types. Some of the more common ones that you'll work with are integers. So these are whole numbers, floats. So these are numbers with decimal places, strings. So these are both letters and words, and even numbers inside of quotations, and Booleans. So these are, the Boolean data type is just true or false. And it's something that we'll talk about a little bit later in this lecture. Okay, so even though we can't do like two strings plus each other, what we can do is assign variables. And I think what we did last time is we said like a variable was my name, and then you put in quotes whatever your name is. And a key difference there is that the variable, even though it's a string without quotes around it, and the computer knows to read that in as a variable type. So in this case, you could say, for instance, x is 5 and y is 4. And you can give the computer these two variables, x plus y, and the answer you'll get is 9 because it assumes, it kind of plugs them in, right? So in this case, they're called variables because they represent an assigned value. And the benefit of using variables is that the assigned value can change easily. So if you just wanted to know what 5 and 4 equaled, you could just put in those numbers and hard code them. But a lot of times, most of the times that we're using computers is because we want to do some process like 1,000 times with 1,000 different numbers, or we want to automate it, or we want to read in numbers from some other file, like from, I don't know, Google. We're trying to mine a bunch of data. So we want to read in all those numbers and do the same operation to it 1,000,000 times. And so in this case, it's nice, instead of having to hard code and type in each set of numbers we want to do some sort of mathing to, we can just assign those values to these variables and get out an output. And you'll also see that later. So a variable, you could assign it to be an integer, a float, a string, a Boolean, any data type really. Another example here is like, you could say x equals the string hello, y equals the string world. If you did x plus, in quotations, a space, plus y, you would get hello space world. If you don't include this space, you'll just get hello world as all one word. So again, these are things you can try out and test when you're working with the Jupyter Notebook. And then conditionals, this is that Boolean data type that we talked about, where the data output is either true or false, or those are like the only two values it can hold. So sometimes you want the computer to do something only when a variable meets a certain condition. And that's actually really common. So the most common conditionals are equals. So like if A equals B, then do this. Another common one is not equals. So that's represented, and I should point out, sorry, that these are the symbols that will represent that conditional statement. So two equal signs means if A equals B. Exclamation point and an equal sign means if A does not equal B. This exclamation point means not. Less than and greater than, I think you're familiar with. Less than or equal to would just be the less than equal sign, and vice versa. So hopefully these aren't that new to you. Maybe the double equals and the not equals are a little bit newer. But these are essentially things when you want the computer to do something only when it meets a certain condition. Okay, so at this point, I feel like it's also important to talk about syntax, because in addition to data types, syntax is the other most common reason why in the beginning people get bugs and errors. So like we talked about, similar to sentence structures in English, the computer needs commands in a specific order and a specific format. And remember from binary, like no extra spaces, make sure nothing is capitalized. It has to be put in precisely the way that it is, it can be read. Otherwise, you will get errors. So in Python in particular, spaces and tabs matter quite a bit. Tabs especially will tell the computer if you're not done with your command, if it's a multi-line command. And that's something that we'll get to later. But even when you're writing these conditional statements, you need to make sure that there's not extra, what do I say, like extra characters in your commands. Okay, so the conditionals are the things like equals to, not equals, greater than, less than, etc. But then we can put these into whole statements. So sometimes you want the computer to do something only when a variable meets a certain requirement. So for instance, there are two main ways. One is called the if-then statement. So if X is true, then do Y. And then the other one are for loops or while loops. And it will say like, for X in this many numbers, do this thing, or while X is true, do this thing. So we're gonna also test and go through these. So an if statement would look something like this. You first have to define your variables. So that's like, for instance, A equals 33 and B equals 200. And then you would say, if B is greater than A, colon, and this is, again, an important part of the syntax. Then you go to the next line, you have a tab, and then you say print B is greater than A. So the statement, the conditional statement that's being evaluated is B greater than A. So in this case, is B greater than A? It's 200 versus 33. So the answer should be yes. And so if that's true, then this will happen. This will print out to the screen B is greater than A. There's also something called an else if. So this adds a second condition, right? So if A is 33 and B is 33, and we say if B is greater than A, print B is greater than A, in this case, this would not print because this is not true. So if you have this statement, nothing happens because we only gave it this first part of the command. However, we can add what's called an else if, which is abbreviated to ELIF. So we could say else if A is equal to B, then do this. So now it has two conditions that it could follow. Either if B is greater than A, it will print this statement, or if A and B are equal, it will print this statement. Okay, so in this case, what should happen? If you type in all of this, you should get the computer to print out A and B are equal because they are. However, you can then manipulate these variables and change them around. So for instance, if you made A equals to 50, then it doesn't satisfy this, right? If A is 50 and B is 33, then B is not greater than A, and A does not equal B, so nothing will happen. So play around with it and see what you think. The final part of an if-then statement is the else call. So we talked about the if B is greater than A, also the else if, which lets you have another condition that they could test. And you can have like 10 else if statements if you want. So you have if, else if, else if, else if this, and else if that. And then the last one is the else statement, which is kind of a catch-all, and you don't give it any condition. So essentially the else part says, if nothing is fulfilled above, then do this, right? So in this case, because we have A is 200 and B is 33, A is greater than B, but the only conditions we're testing are, is B greater than A? And the answer is no. Is A equal to B? And the answer is no. So then this falls into the else condition, in which it would have to be assumed that A is greater than B. If that doesn't make sense, again, we can test it and we'll work through this in the lab. But this is the basic logic. So you can also just jump straight to an else condition. So let's say you only want to know if B is greater than A. Otherwise, you don't really care about it, right? So you would say if B is greater than A, print B is greater than A. else, which catches everything else that could happen, B is not greater than A, right? So you just have to think through the logic of what you're saying and what you can claim. So if this isn't true, then what is true? So here we couldn't print, for instance, I mean, you technically can, but it wouldn't be correct. You couldn't say A is greater than B because there is also that equals case, which we are not testing in this. Okay. So just to review, these are the different formats that an if-else statement could take, or an if-then. It's also called if-then because in other programming languages, the syntax is to write if X, do this, then do this. So yeah, these are some different cases. So if, else if, else if else, and if and else. So we can play around with all of these and you can try different combinations. Okay. The second type of conditional is called, they're either for loops or while loops. And in all of these cases, these are really common structures, so they're not unique just to Python. You'll have something similar to them in Java or C++ or MATLAB, etc. This is really called like programming logic. So it's like, these are the basic types of arguments that computers will intake and need to know how to do. So for or while loops will do something as long as the conditional statement is true. So they're often considered iterative because they will iterate or repeat a command for as many inputs as is given and as many tasks as is true, or as many rounds as the conditional remains true. This is really great for repetitive tasks. So let's say for some reason you wanted to print to the screen every letter in the word banana. You could have something like for X in banana. So this is assigning this variable X with the value of each letter in banana, print X. And what that will do is print out each letter in banana one at a time. You can also use a while loop. So this can be used especially to count through items. So for instance, you have to set the value initially. It's called initializing the variable. So X is initialized or set to 1. Then we say while X is less than 10. So while this value of X equals less than 10, we're going to print the value of X. The most important part of a while statement like this is that you have to increment the value of X. So if we didn't have this line X equals X plus 1 at the end, you would be stuck in this loop and your computer would not be able to get out of it and everything would freeze. So sometimes like when programs freeze or you see the, like on the Mac, it was like a color wheel of death, or on Windows computers, it used to be that timer that would just go back and forth. Sometimes programs will stall out because they forget to close the loops in what's written. I mean, that's not that common because professional software developers shouldn't be doing that. But when you're writing code initially, you may forget to make sure there's a way that the computer can exit out of these loops. So we'll show you this in the lab as well, but these are just some examples. Okay, so all of those are fine. Really what we're doing, it might be a little bit harder to see the utility right now, but you'll see it more as we move on into the like following weeks when we're doing like game development and app development and like programming the Arduinos. All of these are basic structures that end up being really powerful. A lot of times though, we want to do more complicated commands, which will require like many, many lines of code. So, and we want to do them, like, let's say we want to do the same 50 lines of code 100 times. So in those cases, instead of writing those same commands over and over, which is tedious and long, we can write what's called a function. And so a function is basically just a set of commands that can be called and it will do everything you want and just return the output to you. The basic principles of a function are that they take some sort of input and provide some sort of output. But even that part is up for debate. So we've actually already encountered functions quite a bit so far, because a lot of the commands that you're using are actually functions. They're built-in functions in Python. So for instance, the print, when we say print hello world, print whatever, what that is actually a built-in function in Python that tells the computer to take whatever is in between these parentheses and print it out to the screen. So you could say print hello world. But if you look up the function itself, you can Google like Python print function, and you should get a page like this, which will tell you the syntax of how to use that function. So it'll say something like print, then you have the object that you want to be printed. You could also have what's called arguments. So these are additional arguments or parameters that you could use to make the function a little bit more customized or powerful. So if you use this separator parameter, this will tell you how to separate objects if there's more than one. So you remember earlier we wrote hello plus space plus world. Well, another way to do it is to write print hello world and then put the separator as 0 or as space, and that will automatically insert spaces between all of these arguments we give it. There's other things you can do so that you could print this. Instead of printing it to your screen, you can print it to a file, which means it will save these words in a file, like a text file that you tell it or something like that. You could make the text flush if you want. There's a lot of different parameters, especially for a function like print, which is pretty commonly used and also part of the built-in Python set of functions that you get. Another example of a function that we can talk about is the range function. So we're going to use this function in conjunction with some of the loops that we talked about earlier. The range function, basically the definition and usage is it returns a sequence of numbers starting from 0 by default and increments by 1 by default and stops before a specified number. So the syntax is you would type a range, then parentheses, then these are all the 3 parameters that you could have. You could type the start value, which is optional. So you can see here optional, and it's the number that you want to start at. You could type the stop value. This is required. So at the very least, you have to have range and 1 number, and that tells it where to stop. And because we read already by default, it'll start at 0. It'll go from 0 to whatever the stop number is. And then there's also a step argument or parameter that will tell you how much you can increment by. So again, the default is 1, but I could step by 2 and it would step by 2. Okay, so for instance, one way we can use this is in a for loop. So we saw earlier that you could write like for x in banana or whatever, but we can also say that x equals range 6. And range 6, because it has one argument, it has one argument, and that default argument means that it starts at 0 and will go up to but stop at before the number 6. It means that this is essentially x equals all of these numbers, 0, 1, 2, 3, 4, 5. So if I did a for loop and I said for n in x, and we know now that x is equal to 0, 1, 2, 3, 4, 5, I can print n. What this will do is actually print out 0, 1, 2, 3, 4, 5. Okay, so similarly, we could put 2 parameters, and if it's before the 6, then we know this is starting and 6 is the stop number. So it'll print 2, 3, 4, 5. Or we could do the step argument as well, in which case it'll start at 2, stop at 6, and increment by 2. So it'll just do 2 and 4. One tricky thing to note about Python is probably the thing that I think most people dislike the most about Python, but maybe that's just my bias, is that Python is what's called a zero indexed language, which means that it counts the very first value as 0 versus 1, which is very confusing. And that's why a lot of times we just have to like test things out to see what they look like. Whereas like I would say the majority of other languages start at 1 versus at 0, so that you don't have to back count a little bit. Okay, but that's just something, a side note, it shouldn't be that important for you at the moment. All right, and then the last big topic that we'll talk about are modules, packages, and libraries. So we've kind of moved from commands, like single commands like 5 + 5, to conditional statements that are part of like multi-line loops, like if else, or for loops, up to functions, which take inputs and give you back outputs. And we'll also talk about writing your own function in a bit. And then the last part is modules, packages, and libraries. So these are even more complex versions of code. So a function usually just does one simple task. In contrast, libraries are bundles of code that may have hundreds or thousands of functions that do things usually around a central theme. So for instance, in Python, there is a library called the OS module, and it contains tons of functions for interfacing with your operating system. So the OS module will let you navigate file systems, open files, close files, get your working directory, change your working directory, and things like that. Kind of relevant for us are things like the CSV module. This is one that supports reading and writing files, especially CSV files, which we'll talk about in a second. There's also pandas. Pandas is a whole library of functions and commands for data analysis and manipulation. It includes reading and writing files, but it also includes a lot of other things, which we'll see. So it has specific ways of formatting files, and then it has a lot of tools so that you can do specific operations to a data set. There's also one called matplotlib, which I think you might use with Dr. Lane in a bit. So this is a library that has a ton of different functions for plotting data. So plotting your x-axis, plotting your y-axis, changing the colors, making different types of plots, etc. And then there's also NumPy, which is a library for more complex mathematical operations and statistics. So we built into Python natively are things like addition, subtraction, division. But if you want to do something much more complex, like square roots or t-tests or novas, then you'll want to include a separate library from NumPy for that. So the reason these are all separate libraries and why don't they all just come with Python is because Python is such a versatile language and it's used for so many different things that if literally every command and function and library that was written for Python came with it when you downloaded it, it would take like hours or days because there would just be so much. So instead, you can think of these as like modular little toolkits, and you can bring in a toolkit that you need to do a specific function. But you don't have to have that every time you write the code. So like if I'm using Python to write a web interface, I probably don't need the same tools that I need if I'm using Python to analyze my data. So I would only kind of pick and choose the things that I need and import those when I'm using it. So this gets to the topic of importing. So when we work with them, we do have to use the import command, and that's usually one of the first commands that we include when we write new code. So we think about all the packages and libraries that we're going to use, and we write import whatever those are. So in this case, it'd be like import OS because we want to know what the working directory is, and we need that command from that package. And then there's also import, for instance, pandas. This SPD is like a shorthand so that whenever we call a function from the library, we usually have to type the library name, then dot, and then the function. So if the name is kind of long, I mean, admittedly, pandas is not that long of a word, but PD is even shorter. So this has become like a pretty conventional shorthand that a lot of people use, so that instead of writing the whole command out or the whole library out, you just write PD dot whatever your function is, and it saves, I don't know, I guess if you were writing like hundreds of lines of code, it could save like 10 minutes or something, and a little bit of carpal tunnel prevention maybe. Okay. Finally, some of these packages and libraries are what we call native to Python or included when you download Python. And each, I mean, this is going to get a little complicated, but each distribution of Python that you can download, like Anaconda is one essentially Python package that you can download, but there are other ways you could download Python, and they could have more or less of these libraries that are included with the distribution that they're giving you. You could think of it, well, this might be dating myself, but in the old days, when you wanted to install software, you had to use a CD, and the CD would have all the different packages you could include, and you can check them on and off. So it's kind of like that, but some are just automatically included and some are not. Sometimes though, if a package or library is not that commonly used or not included in the distribution you downloaded, then you need to install it separately. Otherwise, the download would be like super massive, like we said before. So using Anaconda, they have this built-in command or function. So you can just type conda space install and then the name of the package. So for instance, conda install pandas, conda install whatever, numpy, etc. In the stuff that we're doing, we're mostly using basic things that you probably don't need this for, but when we move forward, I think some of the code from Dr. Lane will have you install a new package. So you'll use this command conda install, whatever the package name is, and then it'll install that package. You'll want to restart your kernel so that it has the package included, and then you can move forward with the code. Okay. And then when we call a function from a library, we have to reference both the library and the function. So like I said before, this is the library, like OS, and get CWD, which means get current working directory, is the function with the parentheses. And functions always have parentheses after them. That's how you know that they are a function. Same thing with pandas. So remember, we imported pandas as PD. So this is now the module name or the library name, and we can just put pd.read_csv file name. And what this command will do is it will read in a file into as a variable in your interface. Then you can manipulate it and do things with it. And then you can also put it back out as a file. Okay. Finally, for inputs and outputs, and actually I just realized one thing that is a typo here that we'll fix in the lab, but actually to read it out, to save it back as a file. So let's say you read in a file all this data, you manipulate the data and change it, and you want to save it as a different file, you actually would do filename.tocsv. Or, well, a little more, okay, we'll talk about it in the thing, but it's basically you would do whatever the variable name is of the data that you're working with, .tocsv file name. Let's not worry about that right now. It's easier once we see it, but it's also good, I think, to have a full picture of where we're going in the lab today. All right, and then in terms of files and inputs and outputs of files, inputs, computers can take user input from the command line, or they can read input from files. And a lot of times files are much easier because they have a lot of data. So like I said before, if you just want to do 5 + 5, you don't need a computer program or language or a file or anything like that. You can just type it in. But most of the time, if we're going to use a computer, it's because we have like hundreds of lines of data and we don't want to do it all by hand. So it's much easier to read files. However, as with like GUIs and command line, files, different file types have different amounts of formatting that make it easier for humans to read. So Microsoft Word, for instance, you can do spaces, you can do tabs, you can do line breaks, you can bold, underline, you can add, insert pictures, etc. And in order for those files to be human readable for us and make them so easy for us to look at, they have a ton of extra code embedded in them that make it a lot harder and more complicated for computers to read. So on the other hand, there are file types that are really stripped down that we don't really use that often when we're just like sending each other things, sending other humans things, because they're not as easy to format or read. These are things like .txt files, which are text files, and .csv files, which are comma-separated value files. And essentially, a .csv file is similar to an Excel file in that it has like rows and columns in a spreadsheet, except it doesn't have all that extra fancy stuff. So it doesn't have bold, it doesn't have underline. You can't highlight cells and like put colors in them or put figures, etc. It's like a pretty bare bones version of a data file that just has each number or value separated by a comma. And it can be read into Excel, but it also is much easier for the computer to read. So in this class, and I think for the most of the purposes that we'll work with today, we'll use things like comma-separated files or CSV files. Then we will read them in, manipulate the data as a data frame, and then write it back out. Other inputs that are easy for a computer to read are things like matrices. So these are like .mat files and .json files and .text files, like I said. But like I said, these aren't ones that you probably have encountered too much in your daily life just because they aren't things that humans would send to other humans as easily readable files. And then in the lab, we'll also go through reading and writing CSV files. So I just want to note that pandas is one useful option, but actually there are a ton of options. And you may need to do conda install pandas, for instance, if for some reason you don't have it, if it gives you an error that says there is no such library or no such command. But we'll do import pandas as PD. Then you will assign this variable called my data frame, or my df is equal to pandas or .pd .read CSV. This is the function, and then this is the file name week2 CSV. And this is a file that we're including on Blackboard in the content section. So make sure you download it. Make sure you put it in the right folder. So remember again, it's going to be OT699/ in this case week2, where you'll have this file. Then we'll do mydf.head. So these are just like some commands and functions that you can do to manipulate and read and observe the data. And then you can do mydf.csv back to this week2 updated CSV file. So like I said, we'll go through it, but I wanted to give you the overview. Okay, you also in this lab will be writing your own function. So important parts of functions, like I said, they always start with a definition. So it's this word def. Then you have the name of your function. Then you have parentheses, and then you have whatever the input is. So like in the range function, it would be def range input, and then x, because it takes in, well, it could have anywhere from 1 to 3 values. Then you have here, oh, you always have the colon as well. If you don't have the colon, it will give you an error. Then for the rest of this function, you want to make sure that you tab the lines in so that they're all lined up. And when you're done, you will untab, and that's how the computer knows that it's the definition of that function is closed. So in between, you'll have these lines, which are whatever you want the function to do with the input. And finally, if you want it to return a value or an output, you would put that at the end. So in this case, my function, all it does is it takes a variable x that you give it and it adds 10. And then it prints that new value of whatever it was plus 10. And then it will return that value. So for instance, I could say, after I define this function, I can say a equals my function and give it the value of 1. It will go into here and it'll say 1 plus 10. So it'll say y equals 1 plus 10. Print y, which is 11, and then it will return the value of 11. And now because I set a to whatever the output of that function is, a also equals 11. And so if I do print a, it should give me 11. All right. All right, so we're coming to the end of the lecture portion, but basically, in this case, we use Jupyter Notebook because it's quick and easy for you to get started with short commands and seeing output quickly. If you decide to get more involved with programming where you have many lines of code, Jupyter Notebook is not your best option, and you would use something more like Spider, which we had talked about, and which is also an Anaconda navigator, because it will let you type multiple lines of code all together. It also helps you debug a lot of code, and you can also see your variables as they're coming in and out and getting changed by the code. So that's something that I think you will start to work on either next class or like in a few more classes once we start working with more complex things. Today, after the lab, we have one quick assignment for you, which is for you to learn to think about programming and figure out errors and also think through programming logic on your own. So in the last 2 sessions, we've mostly given you the code and all you have to do is run it. I hope that as we're doing this, you also are playing around and tweaking it just to see what happens if you tweak the code in different ways, because that's a great way to learn. And then we have an assignment for you to try to write your own function that will combine a few of the things that we talked about in class today. So you'll write the function. You'll also write 3 test cases of how you would know it worked correctly. So like, what inputs would you give it? Would you give your function to know that it's working? And our goal here is that it will really give you a firsthand look at troubleshooting too. So troubleshooting is probably 99% of programming, I would guess. I don't know, I guess if you get better, it's like 60%, but it's still quite a lot of what your time will be spent on because there's just so many things to know. And like we said, computers don't think about things the same way humans do. So we may assume something should make sense and the computer doesn't have that in its programming. So if you get an error or if you don't know how to do something, Google is your best friend. So I use it. I mean, I used it throughout making this course like a million times already. And anytime I'm programming, I'm always Googling. I always get errors, and then I just have to look up what they are and try to troubleshoot and figure it out. So usually if I get an error, then I'll put into Google the language, like in this case, Python. And then in quotes, I just copy and paste whatever the exact error is. And what that should give you is a bunch of search results that are from Stack Overflow, which is a website where people post questions and errors, and other knowledgeable, kind people with time on their hands post responses and solutions. So as you can see, this type error is a very common question that comes up quite a bit because it's a pretty basic error. And so you could click on any of these and look for different answers for why you're getting this error. Like I said, Stack Overflow is your friend, but you can also Google questions to help you learn the right way to ask questions and also how to do things that you may not know. So for instance, I wanted to use Python pandas in order to multiply a column value, which is like something we'll talk about in the lab, but I can just Google it. And sometimes it will really quickly just tell you exactly how to do it. Sometimes it will give you Stack Overflow with a lot of different similar questions. And in doing this process, at the beginning, it's very time consuming. You can spend like, I think in the beginning, I spent like 2 days sometimes to find the answer to fix one line of code. But that's also why we have this class and why we have the interactive session, so we can talk about it, because we could help you a lot faster that way a lot of times, especially in the beginning. But the Googling process is actually really valuable. And in my lab, at least, we have everybody go through this process when they learn a new language, because it's how you start to understand the ins and outs of the language. Just like when you're learning a foreign language, being immersed in that language and making lots of mistakes and learning the phrases that you need to know often is how you learn best. So good luck. Okay, but I just want you to know programming is so much trial and error and Googling. Once you do it for a long time, you'll start to remember specific commands and also syntax and things like that. You'll run into the same errors over and over again, and you'll start to learn not to do those things. And you'll also mostly learn how to find the information that you need. So I still Google almost everything I want to do, unless I do it all the time. And I think this is true for people even that program for years and years and years, and programming is their job. So I just want to set that as the norm. Hopefully you have a bit of frustration tolerance as you go through this, and I hope that you enjoy it and are learning a lot about what's involved in computer programming. All right, in the next video, I will do the hands-on lab that you can follow along with me.